Very good morning, all of you. So today, as a overview of all the chapters, today we'll see the differences and similarities between the some non-conventional masonry processes. Okay, so through these similarities and differences, you will get the that working principle of all the processes. Okay, and how each process is differ or similar to other. Okay, so for that purpose. Today I am going to take this point similarities and differences. Okay, so before going to that, whether my voice is audible at your end? Okay. So firstly, we'll go for the second chapter, that is the mechanically energy based processes. Okay, and we have learned about the abrasive jet machining and water jet machining, correct? So we'll go for that point. So as we know that abrasive jet machining, water jet machining, again ultrasonic machining and abrasive water jet machining. Okay, they are belongs to the mechanical energy based processes. Okay, that means mechanical energy is used or it is utilized to remove the material from your workpiece. Now, by which action these processes are removing the material? By erosion action. Okay, so in short, I have written that abrasive jet machining, water jet machining, abrasive water jet machining, and ultrasonic machining, that is USM, directly utilize mechanical energy. For what purpose? To gradually remove material. Okay, from whom? From the workpiece. How? By erosion. Okay, so in short, this is a principle. Now let us move for the next. Now you can see here. Here I have shown the schematic diagram of abrasive jet machining. Now you can see here we have our workpiece. Okay, and now suppose from this workpiece I have to remove the material, or for example I have to drill a hole there. For example, again take a 10 mm diameter hole you want to uh, drill a hole in that workpiece. Okay, so if you go with this abrasive machining, then which components you will require for this? No, so you can see as we need abrasive jet machining. Okay, so start with this compressor. We need some carrying gas, okay, to carry the abrasive particles. Okay, we require the compressor, the fresh air we require. So to increase the pressure of that air, we need compressor. You can see here we have taken the air inside, okay, in this compressor. Then whether its pressure is increased or not, you can check using this pressure gauge. Okay, then to control the flow of the your that carrier gas means your air, we require the wall, correct? Then to remove the some dust particles or other contaminant, we require filter and dryer. Okay, so for that purpose this component is placed here. Okay, and then you can give this pressurized air in this mixing chamber. Now in this mixing chamber will have the this abrasive feeder. That means through this abrasive feeder you can take abrasive particles. Now which are the abrasive particles? As we know that Al2O3. Okay, so that abrasive particle you can take inside that mixing chamber. Also from this you have taken the air. So by the pressure of the air, your air, you can feed the abrasive through this mixing chamber. Okay, you can mix that abrasive particle with your air, and with that kinetic energy, or the sorry pressure energy of your that carrier gas, that means air, you can process for further. Okay, again you can measure your pressure here also. Now whatever the your mixture is there, no, that abrasive air mixture you can call. Now here air is just carrier gas, huh? So here you will get the abrasive, and through this nozzle you can strike or impinge your abrasive particle through this nozzle. You will get here jet, and with the high velocity jet of that abrasive jet, you can erode the material from the your workpiece. Okay, so here kinetic energy of your abrasive particle, okay, that is the main for the, your erosion purpose. Okay, kinetic, and due to the kinetic energy only of your abrasive jet, material will be removed by erosion action. Okay, so this is just a simply schematic diagram of the abrasive jet machine. Here also you can see the in detail again. Okay, you can see here in this abrasive water jet machining, abrasive particles are made to impinge or the strike on the workpiece. Okay, with the high velocity. Okay, now to get the high velocity, we are taking the air as a carrier gas. Correct. So that high velocity abrasive particles will remove the material by which action? By micro cutting action. Okay, erosion means what? Okay, small micro cutting particles or brittle fractures will occur on your workpiece. Okay, and that means your erosion. You can see here in the diagram the black spot, whatever you are getting, no, that are the abrasive particles. Okay, that will strike on your workpiece, and then that will remove the that material from your workpiece. Okay, now here one question may arise that at what velocity you can strike your abrasive gas, abrasive air that you can call also. So as per the standard 150 to 300 meter per second velocity, that much velocity you can maintain. Okay, now here please note on this one also, as all these processes are the non-conventional or advanced machining process. That means there is no physical contact between your tool and workpiece. Now here tool is not there, but through this nozzle you are going to impinge these abrasive particles, correct, on this your workpiece, correct. So there we have to maintain the some stand of distance. That means you have to maintain some distance between your upper surface of this workpiece and the lower surface of your workpiece. You can see stand of distance. It is also called nozzle tip distance, and that distance for this process you have to maintain as 0.5 to 15 mm. Okay, this is standard. This diagram I have taken from the NPT that Wikigen book. Okay, so you will get this diagram. This standard diagram. Okay, now let us go for the water jet machining. What आपण बघितलं पहिलं ॲब्रेज जेट मशीनिंग. ॲब्रेज जेट मशीनिंग मटेरियल रिमूव्ह कसं करतो, तर ॲब्रेजिव्ह पार्टिकल आपण कंटिन्युअस स्ट्राईक करतोय तुमच्या वर्कपीसवर, आणि त्यामुळे काय होणार, मायक्रो कटिंग ऍक्शन आणि ब्रिटल फ्रॅक्चर मुळे ते इरोजन होणार, आणि त्या इरोजन मध्ये मटेरियल रिमूव्ह होणार आहे. ओके, आता त्याच ॲब्रेजिव्हच्या ठिकाणी, ओके, ॲब्रेजिव्ह म्हणजे तुम्ही साधं सिंपल जर बोलायला गेलं तर वाळूचं कण जर घेतलं तरी चालते. ओके, वाळूचं खडं जर म्हणलं तर बारीक. आता तसं जर दुसरे मेथड बघितलं मेकॅनिकल, जिथं आपण कायनेटिक एनर्जी वापरू शकतो, तर दुसरे मेथड काय प्रोसेस काय, तर वॉटर जेट मशीनिंग. ओके, सो वॉटर जेट मशीनिंग मध्ये काय करणार आहे, हाय वेलोसिटी वॉटर जेट वी हॅव टू स्ट्राइक और वी हॅव टू impinge on your workpiece. Okay, and with the help of the high kinetic energy or high velocity of your water jet, that material will remove, okay, by erosion action. Same funda. So you can see the schematic diagram here also. Here, as we need some water, okay, so we need reservoir. So here we have the reservoir, that is fluid supply. Okay, that we have to filter and mixer for that purpose. Then again we have to increase the pressure of that your, sorry, from the reservoir you have to take the water. So for that purpose we need pump. Then we have to need to increase the pressure. So intensifier is there, that in it. Okay, as now you know that what is the working principle of the intensifier or purpose of the intensifier, because to increase the pressure or to boost the pressure of any fluid, this component is used. Okay, now whatever flowing fluid you are given, if it is excess, then you can store in the one unit. It is called the storage, or it is also called accumulator. Okay, so accumulator is there, and to control the flow of your that pressurized water, we record controls. Okay, for that purpose we have this hydraulic unit also. Okay, that means control wall is there. Okay, flow control wall, pressure control wall, all these things. Okay, the direction control wall also. And then that pressurized water you can give it to this nozzle. Now that material of the nozzle, normally for this water jet machining, it is a sapphire. Okay, so sapphire nozzle is used. Now again, from this nozzle you have to strike, or you have to impinge your water, high velocity water jet onto your workpiece by keeping some distance, that is called stand of distance, you can see here. Okay, and then by impingement or the by striking of the your water jet continuously, you can remove the your material from your workpiece, and you can create the shape which are you want. For example, drill, or for example, if you want to cut the that plate into two pieces. Okay, you can see there. So this is a schematic diagram of water jet machining. Now quickly I have gone for the working principle of your average jet machining and water jet machining. Now let us go for the which are the similar point between these two. Okay, so basically first point is both are the non-traditional, non-conventional machining processes. Okay, however none of them is considered as hybrid process. Okay, hybrid process nine, because here we are not combining any advanced process with a traditional process. That are both are the purely non-conventional or non-traditional machining. Then average jet machining as well as the our water jet machining, both are mechanically energy based non-conventional machining. Okay, as as they directly utilize the kinetic energy. For what purpose? To remove the material. Okay, in average jet machining as well as water jet machining, both are utilizing kinetic energy, correct, to remove the material. Okay, then both the process require appropriate nozzle. Okay, for both process we require appropriate nozzle. Okay, for what purpose? To convert the your pressure energy of the fluid into the kinetic energy. Okay, so these are the similarities. Again, what are the performance of this your water jet machining or average jet machining does not depend on your electrical and the thermal conductivity and the other chemical inertness of your workpiece. Okay, so what are the profit of your workpiece? It is not affect the performance of sorry, that not affect the performance of average jet machining or water jet machining. Okay, then none of these processes associated with the burr formation or the thermal damage. Okay, here we are not giving any thermal energy or any heat affected zone. So both are thermal sorry, not associated with the thermal damage or heat affected zone or the burr formation. Okay, then both the process can be integrated with the CNC system. Okay, for efficient control. Whatever the I have shown the diagram, that are the old diagram I can see, or just a schematic diagram. But if you go for the automation or the with the modification, definitely you require the CNC integrated CNC system. Okay, for what purpose? To efficient control the precise delivery of the jet. Okay, now come to the difference and similarities. Sorry, differences between the abrasive jet machining and water jet machining. Okay, so you can see I have made two columns. Okay, column you will get the points about the water jet machine. Okay, so first point is that here a high air is the carrier gas. Okay, and the mixing will happen at the mixing chamber. Okay, by taking the abrasive from the abrasive feeder. Okay, so high velocity jet of air abrasive mixture is utilized for material removal. Okay, in case of water jet machining, here a high velocity jet of pure water, high velocity jet of pure water, it is utilized for the material removal. Okay, that means in both cases, as lastly I have mentioned that kinetic energy is used to remove the material. Then the second point, that what are the working medium is there for abrasive machining is dust free and dehumidified air also. Okay, working medium. And in case of water jet machining, your clean water is the working medium. Okay. Now, to increase the pressure of air in case of abrasive jet machining, air compressor is used. Okay, air compressor is used to deliver the pressurized air. But in case of water jet machining, in place of air compressor, here a liquid pump along with intensifier. Okay, liquid pump along with intensifier is used to deliver the pressurized water. Okay, to deliver the pressurized water. Well, what are the air pressure is there? No, in case of abrasive jet machining, it is typically remains within 2 to 10 bar. Okay, and in case of water jet machining, water pressure remains very high, and it is between 2500 to 4000 bar. Okay, then what are the velocity of air abrasive mixture jet is there? No, when it comes out of the nozzle. Okay, usually it remains in order of 100 to 300 meter per second. That means when your what abrasive air jet comes out of your nozzle, that time velocity of that abrasive air jet is 100 to 300 meter per second. And velocity of water jet as it comes out of the nozzle, no, it remains around the 900 to 100, oh, sorry, 900 to 1000 meter per second. Okay, then next, that is in case of abrasive jet machining, there always exists a tendency of glit embedment on the machine surface. Now, glit embedment means what? Embedment for that means एक प्रकारचं तुम्ही म्हणू शकता की चिटकून आहे. Glit means what? Grain particles. Okay, land particles. Okay, so there always exists a tendency of glit embedment. Okay, on your machined surface in case of this abrasive jet machining. So this may affect the surface properties and the surface properties for surface finish and the accuracy. Okay, and its appearance also. In case of water jet machining, it is not associated with the any risk about the any embedment, because there is no abrasive in case of water jet machining. ओके, अब्रासिव्ह जेट मशीन मध्ये काय असणार आहे, अब्रासिव्ह पार्टिकल असणार लहान. त्यामुळे काय होणार, कधी कधी ते स्ट्राईक झाल्यानंतर त्याचं पार्टिकल तिथं तुमच्या मशीन सरफेसवर चिटकून राहायची शक्यता दाट असते. ओके, then this abrasive jet machining, it cannot be employed in food process industries due to inherent risk of abrasive contaminant. ओके, फूड प्रोसेसिंग युनिट मध्ये तुम्ही वापरू शकणार नाही abrasive, कारण की तिथं abrasive particles असतात, कारण it's a contamination also. But water jet machining, it is preferred and hygienic for slicing food items like frozen meat or fish, etc. Now, abrasive jet machining, it can efficiently machine hard metals, including metal. Okay, you can machine hard metals. Okay, including metal. But in fact, this abrasive jet machining is preferred for machining hard brittle metals and the ceramics. Okay, and the water jet machining does not possess enough power, no, because in water, as compared to abrasive, enough power is not there. So for cutting any metal or ceramic, we cannot go for using this abrasive jet, sorry, water jet. So it is only suitable for cutting softer metals like wood, rubber, or leather. Okay, so this is about the similarities and differences between the abrasive jet machining and water jet machining. Okay, now let us go for the one more process. Okay, Now we'll go for the difference between the abrasive jet machining and ultrasonic machining. Okay. Okay. So if you see this abrasive jet machining and ultrasonic machining, so both are mechanical energy based processes. Okay, where your material is removed, so that material from your workpiece is removed by the impact erosion. Correct. So in case of this abrasive jet machining, as we have studied that hard abrasive particles are mixed with here. You can see here hard abrasive particles are mixed with the highly pressurized gas. Now gas means the air you can use, and that mixture is then allowed to come out via this your nozzle, okay, in the form of your that jet. And this nozzle, the whatever nozzle is used, no, so main purpose is that to convert the pressure energy of the mixture into the kinetic energy. And also this nozzle will direct the high velocity jet towards your workpiece. Okay, and this abrasive jet possesses enough kinetic energy, okay, to realize to release the material removal. Okay, by that now high kinetic energy is, that means that due to the erosion action material is used. Now due to the impact of that your hard abrasive, no, erosion will takes place. Okay, so that is about the abrasive. Now let us come to the ultrasonic machining. Now this ultrasonic machining, again, it is a mechanical energy based process. Now what will happen in case of this abrasive ultrasonic machining? Here in this ultrasonic machining, abrasive slurry, that means you can see separately that arrow I have shown abrasive slurry. So abrasive slurry means what? Abrasive particles suspected in a liquid medium. Okay, and that is delivered in a small gap between your laboratory tool. You can see that tool is there. Okay, that tool it is hold by the tool holder. Okay, and using the transducer you can give the momentum. Okay, that means the vibrations. So vibrator tool is there and your workpiece is there. So in between that you have to deliver your abrasive slurry. Okay, and here the tool is given a particular shape, okay, based on the intended profile, and it is vibrated at a high frequency with low amplitude, okay, above your workpiece. Okay, so due to the vibrations of the your tool, that vibrations from the your tool, it will uh, transfer to your abrasive slurry. Okay, that means abrasive particles are there in the liquid. So that abrasive slurry, due to that impact erosion will take place and material will be removed. Okay, so here abrasive in the slurry is there, no, that will erode the material. Okay, so you can see now, see here what are the tool is there that will vibrate. Okay, with the about that your transducer is there, no, magnetostrictive transducers normally use, it is used. Okay, what is the purpose of that? To give the vibrations. Okay, म्हणजे टूलचा जे नॉर्मल टूलचा शेप कसा असतो, जे आपल्याला वर्कपीस जो शेप पाहिजे तो टूलचा शेप दिला जातो. ओके, and in between your that tool small and your workpiece small gap is there, and in between that gap you have to give the abrasive slurry. Okay, now again, what are the similarities? As we know that both are considered modern or advanced or non-combustion processes. Okay, both are mechanical energy based process. That means both are utilizing only mechanical energy for material removal purpose. Okay, and in both cases material removal taking place due to the impact erosion. Okay, please try to remember some keywords: impact erosion, okay, mechanical energy, and both of them require abrasive, okay, for that erosion purpose. Okay, in case of abrasive jet machining, high velocity jet actually contains abrasive particles which are mixed with the clean dry air. But in case of abrasive ultrasonic machining, here the slurry that flows in between the tool and workpiece contain water-based abrasive particles which are suspected in the liquid or which are mixed in the water. That is called the abrasive slurry, and that is used in case of ultrasonic machining. Okay, now which are the abrasives are used in both cases? So here some similar or common abrasives are given that are include alumina Al2O3, then garnet is there, then silicon carbide SiC, and boron carbide B4C. That are these are the common abrasives, okay, which are used in both cases. Again, both the processes are independent of electrical and thermal conductivity and chemical inertness of the your workpiece. Okay, but here the performance or the process capability of the both processes are relies on the several mechanical properties like strength, hardness. Okay, and none of the, that means the abrasive as well as the ultrasonic machining, none of them is associated with the burr formation, heat generation, and the other thermal damages related issues. Okay, here no issue about the heat affected zone. Now come to the difference. Okay, once again you can see at one side you will get the point about the abrasive, in second column you will get the ultrasonic machining point. Okay, so in case of abrasive jet machining, high velocity jet of your air abrasive mixture. Now that velocity, as we know, that 100 to 300 meter per second, that high velocity jet of air abrasive mixture, it is utilized for removal of the material. That is the mixing purpose. In case of ultrasonic machining, high frequency, okay, more than 10, 20 kilohertz, okay, high frequency but low amplitude, less than 0.1 mm. Vibration is utilized for machining purpose. Okay, high frequency, low amplitude. Then high velocity jet is allowed to directly strike the workpiece. In case of abrasive jet machining, high velocity jet is allowed to directly strike the workpiece. Here, in case of ultrasonic machining, you can see vibration is not directly imparted to the workpiece. Okay, vibration is not directly imparted to the workpiece. Instead of that, vibration is imparted on the abrasive slurry. Okay, that flow through the narrow gap between the your shaped tool and the workpiece. Okay, टूल्स जे व्हायब्रेशन असणार आहेत that are not directly transferred to or imparted to the workpiece, but what are the vibrations are there that will transfer or impart to the abrasive slurry. Okay, and then through that, due to that vibration on the your abrasive slurry, it will impact the your workpiece and then material will be removed. In case of average jet machining, it does not require any specialized tool. Okay, interior profile can be cut by moving the work table and rotating nozzle if required. But in case of ultrasonic machining, it is mandatory or it is compulsorily requires a physical tool. Okay, in case of ultrasonic machining, we require physical tool having inverse profile of the intended shape. Okay, जो शेप आपल्याला वर्क वर हवाय, ओके, तो शेप पहिल्यांदा आपल्याला आपल्या टूलवर पाहिजे. ओके, so accordingly shape of the machine feature that will release on the your tool profile. Okay. Now, as we know that, as we have gone for the working principle of the abrasive jet machining, so it requires air compressor come dryer to deliver the highly pressurized clean air. Okay, and this air is then mixed with the abrasive in the mixing chamber, and the what are the pressure energy is there of your air abrasive, uh, that is going to convert into the kinetic energy by the means of nozzle, and thus high velocity jet is obtained. Correct. But in case of ultrasound machining, it does not require any compressor in it. Instead, instead that it requires magnetostrictive transducer. Okay, for our purpose to generate vibration, and also we require a horn. Okay, horn means that tool and the tool holder. Okay, so to deliver vibration at intended amplitude, we require the horn. Okay, so here the main component is that magnetostrictive transducer and the horn, and the tool is mounted at the tip of your horn. Okay, in this ultrasonic machine. Then what are the that abrogate machining is there? So that offers comparatively higher material removal rate. Okay, MRR, material removal rate, and in order of 5 to 10 cubic centimeter per second. Okay, that much MRR we are getting using this abrogate machining. Again, okay, please note down this. Whatever is this, you know. So that is not for the all the material. Material to material removal rate is going to change. Okay, but in case of ultrasound machining, material removal rate is very low. Okay, typically around 0.05 cubic centimeter per second. Now application. So abrasive jet machining can be used for ductile and brittle material. Okay, however, it is prepared for hard brittle materials. Okay, due to the risk of abrasive embedment in the soft material. And ultrasonic machining is commonly used for machining brittle materials, especially those which are electrically non-conductive, like glass, ceramic, and carbide, etc. Okay. Now, in case of ultrasonic machining, in case of abrasive jet machining, it produces extremely noise during the operation. Okay, so abrasive beads are sometimes scattered out of the chamber. Okay, so proper protection is required for the worker. But here, ultrasonic machining is relatively safe in this scenario. Okay, so I repeatedly saying that for this non-conventional machining subject, please refer this advanced machining process by Vikajan book. Okay, soft copy I already shared with you. If you require hard copy, you can take from our library. Okay, we have that also. Then we have the hard copy of this book also, unconventional machining process by T. Jagdisha. Okay, then we have the hard copy of this non-conventional machining by P. K. Mishra. Okay, and the whatever the I've given the some point now that I have taken from this one of the website. Okay, so you should know. And if anybody has missed any lecture, okay, out of that 58 lecture, and if you want to listen, or if you want to watch my lecture, you can visit my YouTube channel, that Let's Learn and Grow Together, or just in YouTube you can write hash LLAGT. Okay, hash LLAGT, you will get the separate our subject, non-conventional machining. Okay, hash LLAGT or hash DT काशीत जरी टाकलं तुम्हाला YouTube वर तरी माझे व्हिडिओ तुम्हाला भेटून जातील. Okay, so this is about the second. Now let us move for the one more. Let us go for chemical machining and electrochemical machining. Okay. Now I am coming to the that chemical energy based and electrochemical energy based process. Okay. So as we know that our non-traditional or non-conventional machining process employ different forms of energy. Okay. In direct form. Okay. To remove the material from your workpiece. Okay. Now in that energy form will get mechanical energy, chemical energy, thermal energy, electric energy, and the combination of any two or more than that also. Okay. Now, in case of chemical machining, how material is removed? Okay. So, in case of this chemical machining, normally this chemical machining, okay, I will just briefly introduce about that, give introduction about the chemical machining. So, chemical machining employs appropriate chemical solution. Okay, to each away some material from your workpiece. Okay, to remove the material, we require some chemical solution, and such chemical solution is called etchant. Okay, and that is highly corrosive chemical. आता इचिंग किंवा इचिंग म्हणतो ना त्याला काय म्हणायचं फॉर दिस प्रोसेस केमिकल मस्टिंग त्याला इचिंग म्हणजे काय मटेरियल रिमूव्ह म्हणतो त्याला इचिंग म्हणायचं ओके सो वेअर वी नीड chemical solution that is etchant. Again, for this process, no separate cutting tool or the shaped tool or similar device is used here. Okay. And whatever the etchant is there, no, that itself react with your workpiece, and due to that, that chemical dissolution will happen due to your that etchant solution. Okay. So it is mandatory to select the proper etchant composition based on your workpiece. वर्कपीस कुठला आहे त्याच्यानुसार तुम्ही इचंट सोल्युशन सिलेक्ट करू शकता ओके सो this process it is independent of your mechanical electrical and thermal properties of your workpiece okay but it totally relies on the it's a chemical reactivity okay chemical reactivity of totally based on okay you can see the diagram also I will show I have that. You can see this is a diagram for the chemical machining okay we have the one tank okay then we have the that in this what we have the agent okay that is chemical solution okay again इचिंग करण्यासाठी जे आपल्याला वर्कपीस पाहिजे तो वर्कपीस तुम्ही घेऊ शकता आणि तो वर्कपीस म्हणजे इथं तुम्ही बघू शकता आपल्याला काय करायचंय बी हे लेटर कोरायचे ओके म्हणजे काय इचिंग इच करायचे ओके एरिया टू बी मशीन दॅट इज द बी पार्ट ओके नाउ टू हीट your etchant solution we require the heating heater coil so you can see heater coil is there okay and that etchant resistance lining also there okay that etchant should not uh, react on your that container wall or the okay, side okay so again agitator means ते डवळे आपण म्हणतो डवळत राहायचं ना ते हीट कंटिन्युअसली हे करण्यासाठी सो ज्या वरपीसचं मटेरियल आहे त्या वरपीसच्या मटेरियल नुसार तुम्ही इचेंट सिलेक्ट करू शकता ह्याबद्दल आपण इन डिटेल केमिकल मशीन शिकताना बोललेलो आहे इन डिटेल ओके बट just for the revision or the for worship purpose I'm showing this diagram then electrochemical machining okay this schematic diagram of electrochemical machining you can see इथं काय होतं आपलं in this electrochemical machining material is removed by ionic dissolution जसं केमिकल डिझॉल्युशन कसं होतं केमिकल मशीनिंग मध्ये इथं काय आयोनिक डिझॉल्युशन होतं ओके, किंवा तुम्ही त्याला इलेक्ट्रोकेमिकल डिझॉल्युशन म्हणू शकता. बट under the assistance of electrochemical reaction that ionic dissolution will happen. Okay, so here no corrosive HT is used. Okay, instead of that, here suitable electrolyte is employed. Okay, suitable electrolyte is employed. Okay, and this electrochemical ECM, it required shaped tool. Okay, made up of electrically conductive metal. Okay, and that is placed close to the your workpiece. Okay, but here also we have to maintain a small gap. Okay, and both your tool and your workpiece are connected with your two polarities of the DC power supply. That means your tool will act as cathode and your workpiece will act as an anode. Okay, and are both this workpiece and your tool are immersed partially into the your electrolyte. Okay, so under the presence of sufficient potential difference, electrochemical reaction will initiate, and it follows the principle of Faraday's law. Okay, and here tool metal and your electrolyte are chosen in such a way that metal from the workpiece only gets dissolved into the electrolyte. Okay, so tool and electrolyte remains intact. Okay, so this electrochemical uh, tool must have profile based on intended profile, because inverse shape of the tool is imparted on the your workpiece. जो वर्कपीस आपल्याला शेप पाहिजे तो शेप पहिला आपल्या टूलवर देणं गरजेचं. Okay, so here please note down this electrochemical machining process totally based on based on the principle of Faraday's law. And here the basic condition is that this electrochemical machining can be applied for electric conductive metal only. Okay, so both tool as well as your workpiece should be electrically conductive. You can see here. Okay, DC power supply ला मी काय केलं, तुमचं टूल पण दिलेलं टूलला बी कनेक्ट केलंय आणि वर्कपीसला. Okay, so workpiece will act as anode, that is positive terminal, and your tool will act as a cathode, okay, negative terminal. And in between your tool and your workpiece there is a small gap. It is called inter-electrode gap, and in between that inter-electrode gap we have to flow our electrolyte. Okay, so due to the ion dissolution, okay, when that ion dissolution or electrochemical reaction will happen, when we will give the sufficient potential difference in between your tool and your workpiece. Okay, so that is the basic principle behind the electrochemical machining. I think for today's lecture, this much part is sufficient. The remaining we will continue in the middle session. Okay, so today I am planning for the in the middle session we have the practical 2 to 3. So that time I will see whether that Bundu Kamesar is there, because I wanted to show some practical about the photochemical machining, because photochemical machining facility we have no in our department. Okay, so if possible today we'll take practical. Okay, in the practice session I will give some the assignment part, because okay, so remaining part I will speak that time only, I will tell that time only. Don't worry. Now please don't leave any so don't anybody please don't leave this meeting. I am taking your attendance now. ज्याने ग्रुप सोडला त्यांची absentee लागेल, पुन्हा म्हणायला मी होतो. ज्यांनी पहिल्यापासून लेक्चर अटेंड केले त्यांचे अटेंडन्स चांगले आहेत. जे मधनच आले जॉईन केले त्यांचे म्हणजे अर्धे लेक्चर बुडवलेत त्यांचे अटेंडन्स कमी आहे. ओके, बरेच जण म्हणतात की मी लेक्चरला होतो सर अटेंडन्स कमी. अरे एखाद्या लेक्चरच ठीक आहे की. ओके, धरून त्याला एखादं 20% अटेंडन्स आहे आणि ते जे कसं लागेल बॉस 70%. ओके, माझ्याकडनं एखादं मिस्टेक धरून त्याला 1-2 लेक्चर 20-25% होऊन जाईल. पण 20 तर डायरेक्ट 70% होऊ शकणार नाही ना, एवढा मोठा डिफरन्स राहणारच नाही. ज्या टायमाला तुम्हाला नोटीस आता दिले मागच्या नोव्हेंबर महिन्यात, तेव्हापासून स्ट्रेंथ वाढली. अदरवाईज पहिले कमीच होती ना. ज्यांनी खरंच अटेंड केले त्यांना माहित आहे. Okay, so I have taken attendance. 55 students are present. Now we can leave the this meeting. Thank you. Thank you very much.